Welcome back, Mathville. Today we're going to be verifying trigonometric identities. This is part 1. This is like working proofs again or working puzzles based on what you know. You know, when you play games, you can only make a move forward if you're following the right rules. So that's what we're going to be concentrating on today. Okay, before we begin, you have to get some things together. Get out your trig identities for reciprocal functions, quotient identities, Pythagorean identities, and odd and even functions. You may want to make a one-page chart of these things, and that's a big old hint that I'm suggesting that you really do. It's really a great hint. So if that's the case, pause this and go get it, or stop it and go get those things and get them organized and bring them back. It's going to be a big help. Okay, so we need to use fundamental identities to verify other identities. This is like proofs. This is like when you were in geometry and you were trying to prove that one triangle is congruent to another triangle. You had to go through certain steps that you knew to be true in order to get to that. So verify and proof or prove is going to be like the same word. So if we have two things that are equal, the left side and the right side of a trig identity or an equation, what we want to do is manipulate or use identities on one side to prove it's equal to the other side. And we're going to work a bunch of examples to show you that. Okay? You are going to only manipulate the more complicated side. In other words, you're going to have a left side and a right side. You're going to pick which side you're going to fool around with, and you're going to leave the other side alone until you get the side that you're working with equal to that. Okay, so here's our first example. We want to, and one of the strategies is to change sines and cosines, change everything to sines and cosines to verify an identity. So here's an example. If we have secant x times cotangent x equal cosecant x, we want to prove that that's true. The more complicated side of this equation is the secant x and cotangent x, so that's what we're going to work with. We're not going to do anything to the cosecant x. We're going to try to make the left side equal the right side. So one of the things we can do is we change everything to sine and cosine. Secant x is 1 over cosine x, and cotangent x is cosine x over sine x. So if we do that, we're going to try to prove that's equal to cosecant x. We're not even going to write cosecant x down again until the very end. Well, if you have this on the left-hand side, then you can cancel the cosine x. So this is equal to 1 over sine x, and lo and behold, 1 over sine x is cosecant x, so we have cosecant x equals cosecant x. We've proven our identity. Example 2, sine x times tangent x plus cosine x equals secant x. Well, what's the more complicated side? Well, obviously it's the left-hand side, so that's what we're going to manipulate. So what we're going to do is we're going to change sine x times tangent x to sine x over 1 times sine x over cosine x, because that's tangent x, plus cosine x over 1, and we're going to set that equal to secant x. Now, if I take my sine x times sine x over cosine x, I get sine x squared over cosine x plus my cosine x over 1. And that will give me, actually what I need, I kind of skipped a step here, so we're going to have to go back and do it. If I have cosine x, well, let's get something a little better than that. Let's back up here. Let's get this. If I have a common denominator of cosine x, I'm going to have to multiply this cosine x times cosine x. So I'll have sine squared x plus cosine squared x over cosine x equals my secant x. And now, if I go on, I will have sine squared x plus cosine squared x is equal to 1. That's Pythagorean identity. So I'll have 1 over cosine x, which is secant x. So secant x equals secant x. and I have proven my identity. Right here, that goes back up to here. Okay, example number 3. Sometimes if you look at your, and before you even start to work an identity, you need to analyze it. What is it that I think I can do? And sometimes you can factor things out. So if I have cosine x minus cosine x sine squared x equals cosine cubed x, obviously my more complicated side once again is the left. And so I'm going to change this. I'm going to factor out a cosine x. So I'll have cosine x times 1 minus sine squared x, and that would be equal to cosine cubed x. I'm not going to write that down though, because I'm not manipulating anything but the left-hand side. And I know if I look at 1 minus sine squared x, you need to recognize that this is part of the Pythagorean identity. Sine squared x plus cosine squared x equals 1. So if I subtract sine squared x from both sides, I get cosine squared x. You need to write this down, think about it, and remember it, because this is something that's going to come up many, many times. So cosine squared x can replace 1 minus sine squared x. So I'll have cosine x times cosine squared x, which is cosine cubed x. Example number 4. We can use more than one technique. We're going to talk about 2 techniques for this particular one. And the first technique is we're going to separate the problem into 2 terms, because we have denominators going on here. And the second way, we're going to change everything to sine and cosine. You can choose however you want to do it, as long as you get the final answer. So if I have the problem 1 plus sine theta over cosine theta equals secant theta plus tangent theta. Obviously the most the side we probably should be working with is a 1 plus sine theta over cosine theta, or you can work with the other one too, but I'm choosing to do it on this side. And what I'm going to do is I'm going to divide up or divvy up that 1 plus sine theta over cosine theta to 1 over cosine theta plus sine theta over cosine theta, and I know that's equal to my right hand side. Now 1 over cosine theta is secant theta, and sine theta over cosine theta is tangent theta. So I have my identity, because that's what I'm trying to prove. I'm trying to prove that that's equal to secant theta plus tangent theta. On the other side, if I want to do it changing everything to sine and cosine, start off with my 1 plus sine theta over cosine theta equals secant theta plus tangent theta. And now I'm going to manipulate the right-hand side by changing everything to sine and cosine. So this will be 1 over cosine theta plus sine theta over cosine theta. And I have a common denominator, so that's going to be 1 plus sine theta over cosine theta. And that gives me the answer that I'm looking for. Okay? So after these 4 examples, go do your checkpoints. Your checkpoints are going to be really important with this. Make sure you get them done. You probably will want to put them on a separate sheet of paper. On your video viewing sheet, you're going to say "See attached," so that you can work all these out. And we will see you all back in Mathville. Bye.